Good morning, everyone. Today is December 15th, and we are having a webinar for a comparison of Creo Simulation products by us being Boundary Systems. And we will get underway here now. So today what we are looking to do is review and demonstrate all the FEA or simulation products that PDSVISION currently offers for Creo Parametric. So we're going to start with a little introduction, talk about this concept of a digital thread, and then go right into the meat of the webinar, which is going to be a structural thermal modal example of our FEA products. I will then go into a lab demonstration and open it up to a question and answer. As an overall concept, you're all muted. If you have any questions throughout the webinar, please feel free to either put them into the questions pane or the chat. I'll be checking both throughout the webinar, and I'll answer your questions towards the end of the webinar. So a little bit about myself. My name is AJ Vetterini. I have a Bachelor of Science in Engineering in Aerospace and Mechanical Engineering. And I have about 5 going on like 6 years with CAD and CAE tools, specifically Creo Simulate. So a little bit about us. We are PDSVISION, also known as Boundary Systems. We are a technology leader. We are part of the first PTC global reseller group, being PDSVISION, and are a preferred service provider for PTC products. In terms of capabilities, what we do, we have a wide variety from consulting on anything from CAD to Windchill to other softwares, which we'll talk about in a moment, implementation of many different softwares, specifically Windchill. We offer various trainings on many different of the softwares we'll see, cloud services and data management services, as well as help desk services. At the bottom of the screen, what you'll see is a little timeline kind of showing where we were and where we are today. So we were founded back in 2006, and throughout the years, we've become things like a Windchill partner. We've been acquired by the PDSVISION group, which gives us this whole global presence, which you see on a map here. We have offices. We are headquartered in Cleveland, Ohio, but we also have offices in Europe, which you see in the map, as well as South America, India, and the UAE. Outside of just those basic Creo products or those PTC products, we also offer, various other softwares, which you see on the screen here. As a shout out to a couple that are related somewhat to today, we see like MoldX 3D and Cymerix. MoldX is a mold flow simulation software. Cymerix is a CFD tool, computational fluid dynamics simulation. So similar to today, but will not be the heart of the interview. Today, we're focused on FEA tools. A little bit about the digital thread. This concept of digital thread is bringing all facets of your company together into one specific closed loop. Today, you see this little red circle. We're focusing on the simulation aspect of the tool. And to get a more holistic view of what this might mean, here we see a basic conceptualization of a digital thread. The digital thread would be this green line. What we see are some org charts of various departments, and the digital thread is what's going to be connecting and linking them all so that information can kind of flow between department to department. If you're interested in this concept of digital thread being, bringing everything in your company into one closed loop, we're going to be having more webinar series discussing this in a more holistic view and discussion in the coming months. But to get into the meat of today's webinar, which is a simulation product comparison, the 3 main products we're going to talk about today are Creo ANSYS Simulation, Creo Simulation Live, and Creo Simulate. So right here on this overview slide, I have a kind of just 10,000 foot looking down overview of each product. I'm going to start in the leftmost column being Creo ANSYS Simulation. So Creo ANSYS Simulation is a CPU-based tool, so does not really require any specific GPU. As of Creo 8, it's using the ANSYS Mesher and Solver, and specifically it's using the 2020 R1 Solver in Creo 8, but that is Creo version dependent. Creo ANSYS Simulation is currently only available in Creo 7.0.2 and later. So Creo 7 and 8 specifically is where it is available. As of now, it's a pretty relatively new product still. Again, it was only introduced just last year, around just about now, about 13 months ago. And it currently only supports linear simulations. So we still have linear structural simulations, modal simulations, and thermal, but nothing like transient thermal is currently not available. But there is a distinct roadmap for the future to add more and more functionalities in the coming Creo versions, being Creo 9 and Creo 10 are currently on the roadmap for added functionalities. A little bit more on the technical side, Creo ANSYS Simulation is an H element solver compared to the P element solver, and also is accuracy dependent. So it is very much so recommended to have absolute accuracy on your part files and assemblies when you're using Creo ANSYS Simulation. That is a default setting in Creo 7 actually for new parts getting created there, but that is something that goes into the solver of Creo ANSYS. So Creo ANSYS Simulation. Next off into the middle tab, we have Creo Simulation Live. This tool was introduced around Creo 5 timeline-wise, so a few years ago. But it is actually a GPU-based solver. So this actually requires you to have a CUDA-enabled graphics card. So there's some actual hardware requirements on the side of Creo Simulation Live. It is an ANSYS product, so that is incorporated into Creo Parametric. So it uses the ANSYS solver. Currently, as of today, in Creo 8, it has FEA and CFD support. So in terms of FEA, we can do thermal, structural, and modal analyses. And for CFD, we actually have transient and steady state simulations for fluid flow. In terms of drawbacks, what are the limitations of Creo Simulation Live, or just a couple here? This does struggle typically with very large assemblies containing smaller parts. So I have an example down below of just like a framework where maybe overall size-wise, this is very large, but certain cross-sectional dimensions of maybe the beams may be very small compared to this overall size. So that's an example of somewhere where Creo Simulation Live struggles. The reason being is that it's technically not, there's no mesher involved. It's a quote-unquote meshless environment. And so it's all based on the way the GPU sees the CAD model. So that is one thing to note about this software. Also, if you work in like a field of like hypersonics or anything like that, or you're concerned with high frequency ranges, a limitation to Creo Simulation Live is that it only supports the first 6 modes of a modal analysis. Lastly, the tool we have is Creo Simulate. This is the tool that's been around for a while that PDSVISION has developed. It's an in-house tool. It is also a CPU-based tool. It has a mesher and solver developed by PDSVISION, like I said. And this is a full-fledged FEA tool. It has support for things like nonlinear materials, nonlinear contacts, and nonlinear analyses, which is currently not available in either Creo Simulation Live or Creo ANSYS Simulation. On the technical side, it is a P element solver, and it is also accuracy dependent. It's recommended to use absolute accuracy when you can, but it can solve, all of these softwares can also solve with relative accuracy on your parts. Now, to answer one question that might pop up that is a common obvious question is Creo ANSYS Simulation poised to overtake Creo Simulate, and will Creo Simulate go away? The current answer is no. PDSVISION has no motivation or reasoning to actually get rid of Creo Simulate. So the current path moving forward is that all 3 of these products will be available in Creo Parametric going forward. So to actually compare these products, I have some test cases with some theoretical results, so we can just kind of see what the accuracies of these look like, because that's a big point of simulation tools, right? Is how accurate are they? How much can I trust them? So right here, I have a cantilevered beam. And I have some basic assumptions up here with a length of a meter, a force of a kilonewton coming downwards as W on the screen in the image. And we're just assuming a Young's modulus of 200 gigapascals. The cross section is 50 by 50 millimeters. And using the equations you see on the screen, you can actually calculate what the max stress and max deflection of this beam would be theoretically. This just comes from a pretty much standard statics class. In terms of what our simulation products can see from simulation, we see Creo ANSYS Simulation is the most accurate, within 1.7% for stress and 0.04% in displacement, followed up by Creo Simulate, followed then by Creo Simulation Live. Now, one thing to note is that I did not do any mesh refinement. I assumed, essentially, if you were very new to FEA and you just modeled something and ran a simulation on it, what would your results look like? And this is what we would see. So we see Creo ANSYS Simulation is overall the most accurate. In terms of displacement, though, the one thing I want to note is all of these softwares are able to get pretty close to the true deflection of a cantilevered beam in this example. So that could point to, allowing you to use any of these softwares for displacement. But if you're concerned with maybe getting most accurate stress results, Creo ANSYS Simulation does seem to, at least for this test case, give you the most accurate. The next example I want to talk about that really shows the power of Creo Simulation Live is a very large assembly or complex assembly. So I have a very simple test case here set up. We have the back face of this engine block fixed. We have a moment load coming on this face, and all parts are aluminum 2014 material-wise. And what we see here are the results of the simulation. And what I really want to draw your attention to is the time for a solution. So we see Creo Simulation Live is able to really get us a simulation within about 20 seconds, whereas a tool like Creo Simulate or Creo ANSYS Simulation is going to be in the realm of hours. And so yes, Creo Simulation Live's accuracy of results might not be as trustworthy. So if you're looking for strictly numbers, Creo Simulation Live is not the tool for you, and that's not its intended purpose. But what Creo Simulation Live shows is that it's going to get you a solution within about 20, 30 seconds maybe. You are able to make many design changes to this very complex part and consistently get results. At a bare minimum, you'll be able to see trends in your FEA simulation results that reflect on your design changes. So if we start making cutouts of this engine block, for example, we'll see every 20 seconds, we could see new FEA results, stress results, displacement results. Whereas in Creo Simulate or Creo ANSYS Simulation, if we made a design change in that block, that's another 3 hours of time spent meshing and running a simulation to see what the results look like. We make another change, that's another 3 hours. And so, although you're getting more accurate results, you're spending much more time in the design process. So Creo Simulation Live is a perfect tool for the designer level to make changes and see what those simulation results might be. The next type of example I have is a thermal example, and I have a simple wall heat transfer. So we just have a rectangular cross section. We have temperatures on both ends, a thickness of 0.1 meters, height of 1 meter, and we're assuming the beam is very long, or i.e. 10 times longer than its height, so 10 meters at least. And I just don't have any input heat. And from a theoretical calculation, we should get a thermal energy of 258 watts. And so we see with a thermal test case simulation, we see that Creo Simulate and Creo ANSYS Simulation actually calculate out in a similar fashion. They get pretty much the same exact result, which is very accurate. Creo Simulation Live lags behind a little bit, and in terms of accuracy, at 10% of inaccuracies there. The next test case example I have is a tuning fork modal analysis. So I have my assumptions on the screen here with a theoretical calculation for what the modal frequency of this tuning fork would be, which is a known entity. And here, what we actually interestingly enough see is every software is very accurate to calculate out this modal frequency, which points to the fact that for modal analyses, if you're working within the first 6 modes, you can actually be pretty confident in any of these softwares because the modal analysis overall is a pretty idealistic calculation. We're calculating out eigenvalues and things of that nature. So these are all pretty good softwares if you are working with modal analyses. And now I'm going to go into a demonstration that really highlights each of these softwares before opening it up to a question and answer. So the first one I want to start with is actually explaining where Creo Simulate really shines. So this is just Creo Simulate, and what I have here is just what is essentially a seal getting pushed down. And this seal I'm saying is a urethane material, which is a non-linear material. We see it in our definition here. And this is something that currently Creo Simulate is only capable of doing as of today. And so if I come and look at my results, the benefit to this is we can actually see true deformation of a nonlinear material such as urethane. Where this might be really helpful is if you do a lot of like gasket work, for example, and you want to analyze your gaskets, see if they hold watertight, see what they're, how they press into your housings, for example, might look like. This is where this tool can be very helpful. And again, this is the only tool in Creo's or in PTC's simulation product line that can actually offer this capability. And so as I zoom in here, what we see is the urethane ball here kind of just fills into this cavity of this part because it is a nonlinear material. And so that's an example of where Creo Simulation shines in its current form. Being that it offers the ability to do nonlinear materials. And on top of this, it does also offer up the ability to do like nonlinear simulations. So if you find yourself doing vibration table testing very consistently, Creo Simulation offers the ability to do dynamic frequency responses, which can be used to mimic, for example, vibration table testing. So I will stop this and I'll just close out. And I will minimize this guy. The next one I'm going to bring us into is an engine block. And this one here is going to really highlight Creo Simulation Live. We see Live Simulation is a built-in tool to Creo Parametric. It has its own dedicated tab. But overall, it is a little bit of a more basic tool. We don't get all the loads and constraints that you might be able to see in Creo Simulate or in Creo ANSYS Simulation. From here, the benefit, again, is time to solve. So if I were to run a simulation and give it a moment to kick up, we would start to see results pretty quickly. Now, I ran this a bit earlier, so it actually kind of has the results, but we see it recalculates out within about 10, 15 seconds here. But to prove to you that this does, calculate out very quickly, if we stop this, and I come into this part, and I just resume some cuts. So we see this cut now, and let me do 24 as well. So we get a couple of cutouts. If I were to go into a tool like Creo Simulation or Creo ANSYS Simulation, we would need to remesh it and then run a simulation, which for something of this size and complexity might take hours. The benefit to Creo Simulation Live is I could come in here now, click on Simulate, and give it a little bit of time to figure out the geometry. And we start to see results. Again, within about 15, 20 seconds here, we'll start to see recalculated out results. And so we could determine, hey, this stress value started going up because of these cutouts. But we're still very low compared to like a material stress. And that is what Creo Simulation Live strives to be. You, as a designer, are able to make quick design changes, such as those cutouts, and see what the results look like. You can get trends of data and start to see which of your changes actually helps out the overall structural, modal, or thermal performance and get those results very quickly. But these wouldn't be numbers you would want to report out to like a design review. Again, these are inaccurate. These do have inaccuracies to the actual data that a true FEA CPU-based solver like Creo Simulate or Creo ANSYS Simulation would provide. The last tool I have to talk about is Creo ANSYS Simulation. So Creo ANSYS Simulation is also built into Creo Parametric. And the cool thing about this tool is we do get full constraint and load support. And another big positive to this tool, as it is new, is it is getting new functionalities added to it as the Creo versions are increased. So overall, it still has the nice Creo feel to it. The icons are kind of where you'd expect them. We also do get the ability to look at an ANSYS mesh and see how ANSYS meshes this object, which we could turn on and off and refine through their options here. And we could quickly show it on and off here. We also have the ability as an FEA tool, right? Loads, constraints, and this one does offer basic contacts between an assembly, which is essentially a bonded contact in this case. And we're able to see results. We can activate results in here and start to analyze things. So we could see this data. Some other benefits to this tool, if you are a company that maybe uses the full-blown version of ANSYS Mechanical, you do have the ability actually to save out your simulation data from this tool into an ANSYS Mechanical format that you could import into ANSYS Mechanical. Benefit being there is you could spend a lot more time in your Creo workflow, adding constraints, adding loads, and all this will get brought into Creo ANSYS Simulation, or maybe you are concerned with like a drop test, which is a functionality currently not in ANSYS Simulation, but is planned to be here in the future. The last thing I have to say about Creo ANSYS Simulation specifically is that it is part of the Discovery product line of ANSYS, if you had that question. And so those are the three products and kind of highlights what they are capable of doing as of today. And so to come back to my PowerPoint, I highlighted earlier that we, being PDSVISION Boundary Systems, are able to do professional training. And so if you actually have any desire to learn more about Creo Simulate, Creo Simulate Live, or Creo ANSYS Simulation, we do offer trainings for these and have certified trainers in each of these topics. In terms of where we can train, we can do virtual trainings, in-center trainings, or on-site. So we do have training centers available to our use. And we could also come on site or do virtual trainings. So I'm going to open the floor up to question and answer. I see there's a couple questions in there right now that I'll get to. As a note, if you have any questions down the road, my name again is AJ or Anthony Vetterini, and my email is on the screen here. And also other webinars like this are on our YouTube page if you ever want to look at those. So now I will come and look at some questions. The first question I see is, would there be an error distance or error difference be from this version, Creo ANSYS Simulation, to something like ANSYS Mechanical? The answer would be no. This software is using ANSYS's mesher as well as ANSYS's solver. So there would not be any difference here. The only differences you might see is in ANSYS Mechanical, you do have the full tools available to your use. So if you change anything inside of ANSYS Mechanical, add new loads, add whatever, that would obviously cause a difference. But in terms of apples to apples, Creo ANSYS Simulation to ANSYS Mechanical, as long as ANSYS Mechanical is using the same version solver as you, which in Creo 8, again, is 2021 R1, there would not be any difference between the two. My thing is glitching out. Were all the comparisons done with 3D elements, or was any comparisons done between 2D shell elements? That's actually a very good question. So that is another area where currently Creo Simulation shines. Creo Simulate does have the ability to do 2D shell element simulations. One drawback of Creo ANSYS Simulation is that as of today, being December 15th, 2021, Creo ANSYS Simulation actually doesn't have support for 2D shell elements. There are plans to get that added into it. I can't say exactly when. I'd have to follow up and figure out that date. But yeah, as of today, there is no 2D shell element. And in terms of a roadmap, again, I also don't have that, but I will look for one and hopefully point you in the correct direction. The last question I see is about licensing. So licensing for each of these softwares, they all have their each individual licenses. Creo Simulate has started to be included with specific versions of like a Creo parametric. So I believe like Creo Design Essentials comes with a basic version of Creo Simulate, but all of these softwares do have their own specific licensing. So Creo Simulate is, there's a simulation license and then an advanced simulation license. Creo Simulation Live has its own license, and then Creo ANSYS Simulation is also its own license. And none of these, Creo Simulation Live and Creo ANSYS Simulation, to my knowledge, aren't included with any of the base license bundles as of today. But yeah, these are all licensed individually. From there, real quick. So those are the questions I've had through the webinar so far. But to repopulate the slide, again, my email is on screen now, so I'll make it big just in case. Unless any other questions come in, I'm going to kind of close out the webinar here shortly. But if you think of anything else between now and whenever, feel free to send me an email. And again, I want to highlight that if you were to go on YouTube and type in boundary systems, we have a ton of webinars on simulation products, on Creo Parametric, on Windchill, Windchill 12. There's tons of more and more webinars that we're doing on a weekly basis here. But right now, this will be the last one for the year, for the holiday season. One question I just got in now is, what are the hardware requirements for Simulation Live? And if I come back to this slide, we see here it's a CUDA-enabled graphics card, which is an NVIDIA graphics card. There is a specific list of approved CUDA cards that PTC has that I'll send you. But overall, in general, if you have an NVIDIA CUDA-enabled graphics card, I'll show mine in a moment, Creo Simulation Live would work. And there's also a tool you can use to check your graphics card. And another question about licensing is, can these be licensed per seat, or can they be floating? I have to check for ANSYS simulation. I know Creo Simulate Live and Creo Simulate themselves can be floating options. And real quick, let me give you an answer. Yes, they can all be set in floating options. So for those two questions, Creo Simulation Live does require a CUDA-enabled NVIDIA graphics card, and these all have floating options: Creo Simulation, Creo Simulation Live, and Creo ANSYS Simulation. And to just explain, or to show what my graphics card is here momentarily, I have a Quadro P5200. This is on a engineering laptop. So if you have that, you will know that Creo Simulation Live does work. It works for me. And so with that, I will show my email again and come from my current slide. I'll wait about another minute here if there's any other questions, but outside of that, I will close out the webinar here in about a minute. This will be the end of the questions. I'm going to close out the webinar. All of you have a good rest of your day. And again, if you have any questions going forward, one quick one that just came in is about 3D and 2D. Again, Creo ANSYS Simulation does not have any 2D support. So yeah, it doesn't matter if you're in thermal or structural mode. It does not have 2D support as of today, but that is planned for the future. So yeah, there's no 2D shell elements in Creo ANSYS Simulation today. But with that said, I will close out the webinar. And if you have any other questions down the road, please feel free to email me and I'll get back to you. All of you have a good rest of your day and a great holiday season. Thanks.